As Sir introduced about today's afternoon session, so we are going to see about the end-to-end framework for 5G, especially using millimeter wave technology. So I would like to introduce FR1 and FR2. I think we have totally the entire frequency band broadly categorized into four segments. That is frequency range 1, frequency range 2, frequency range 3, frequency range 4. But 5G have two different FR, that is FR1 and FR2. FR1, we call it as sub gigahertz, less than 7 gigahertz. That means in the order of megahertz to up to 6 gigahertz, the subband, this is called something like we can even still call a non-standalone architecture. That means NSA. So I think if you look at 4G, maximum it functions with so-called 2 gigahertz, whereas this one, what is that 5G FR1 ranges from more than 2. That means more than 2 megahertz, sorry, 2 gigahertz to 6 gigahertz. That is FR1 range. Whereas FR2 range, that is a higher frequency range, which starts from 24 gigahertz to 100 gigahertz. So please understand, when we have a more frequency spectrum, we will have a more coverage, more quality of service, more quality in terms of the reception of the information. So all these things we will be dealing with respect to FR2. So I think I'll start. mmWave fall under FR2 category, not under FR1. FR1 is non-standalone architecture. That means NSA. That means that coexist with 4G as well. So if you look at, this is what the overall agenda of my talk, that goes with the introduction of mmWave and the demo using NS3. So if you look at quickly, I just 10 minutes time I wanted to spend in terms of uh, entities present in the 5G mmWave architecture, for which I wanted to talk about this. That is what when we look at with respect to 4G and 5G, I just used a different color. 4G, I mentioned about the yellow color here to specify how much is the, I think yesterday's session, even that I explained to you our requirement in terms of 4G, the expected delay in the order of 10 milliseconds. 3G 100 milliseconds delay, with respect to 4G 10 milliseconds delay, 5G 1 millisecond, 6G latency is going to be 1 microseconds. So if you look at 7G, 8G, I think I forgot to tell you yesterday, I talked about only 6G. Even we have a white paper in terms of 7G. We can talk to people who already gone up. So that is what is the technology that is with respect to 7G. So what I'm trying to say with respect to, as I said, the 6G, we will able to smell or sense the sensing technology also to be incorporated as part of the system with respect to 6G. 7G, which is going to be a different planet. That means, as I said, a sample, as a layman terminology, we can talk to the people who already gone up. So that is what is the 7G forecasting. So maybe the successor of generation may experience about 7G even. So now let's quickly see what we are currently experiencing 4G and beyond, and the upcoming meaning with respect to deployment practical aspects 5G. So that is pure deep dense, denser red color about 5G, whereas 4G is about in terms of the delay, as I said, 10 millisecond, 5G in terms of 1 millisecond delay, and more users, the traffic volume in per square kilometer is more, and the user experience data rate is in the order of gigabits per second, that's 5G, and whereas 4G is only 100 Mbps, and with respect to end-to-end latency is 1 millisecond in 5G. So these are all the performance requirements, efficiency requirement in terms of system. So as a end user like you and me come under the category of performance requirements, that is quality of service, quality of experience. With respect to system, that is a spectral efficiency. What is the unit of spectral efficiency? Bits per second per hertz. So data rate, we say how much we can be able to transmit or upload or download per second. That's what bits per second. Uh, Over hertz, how much you can do. That's what is spectral efficiency. Bits per second per hertz. That is what spectral efficiency. And energy efficiency, that is again important performance metric with respect to system. And the cost is also must be effective. So why all the cellular technology becoming a successful candidate? The reason why it has got a lot of backward compatibility. Even today's phone having a support of 2G with 2G support backend compatibility. So it is not completely removing 2G and building newly 3G element. It is not completely removing 3G and building a new. It's not that way. It is every success technology is having predecessor backward compatibility with the predecessor technology as well. So this is what is the insight about 4G versus 5G. And as I mentioned already, sub gigahertz up to 6 gigahertz band, that is what is for FR1, whereas FR2 range is from 24 gigahertz to 100 gigahertz. I think 6G, as I said, it is in the order of 300 gigahertz. So we will have more quality, low latency, more coverage. So which impacts to coverage, capacity, how many users, simultaneous users, performance. So everything matters with respect to this particular frequency range FR. So as I used this slide already yesterday's class, because I- I'm talking about this with respect to EPC. That's evaluated packet core. It consisting of few elements. As I said, mobility management entity, MME, serving gateway, and the packet gateway. These three things are the important elements of EPC in terms of 4G. And the E node B is the tower with respect to 4G. The entire system is nothing but EPS, evaluated packet system. We are migrating from 4G to 5G, and with respect to 5G, year and after, it's called 5G core, 5GC, and we will have a new radio that is nothing but G node B. So no, in 5G system, the towers are year and after called G node B. So only in 4G it's E node B, 5G it's called G node B tower. So I think I will be talking to you in terms of as morning speaker would have told you about all the functionalities. I will not be going so detailed way. I'll just tell only the end to end, as this is a 5G user equipment. This is NR 5G NR, that is your next generation node B. That's a G node B. That's why next generation is called G. See, G node B, that is user plane with respect to management function, that is SMF, service management, session management function in terms of user, AMF in terms of access and mobility management. Whenever user is moving from one location to another and providing the access, all these things we have a AMF. So I think if you look at 4G, we have two control plane. One is for control, other one for data. But whereas in 5G, the control plane, these are all the functionalities have been integrated. So with user data convergence with respect to user aspects, that that is to be configured through SMF. This is with respect to access. That is a control plane. Especially this is a control. This is a user. I think all the elements we will talk as and when required. So this is the overall architecture of 5G. So if you look at as I mentioned to you already, this is your authentication server function. This is access and management function. This is session management function. So I think why I mentioned about this now. So in turn, this will have a control with respect to user equipment as well as radio access. This is what radio access means. G node B. So the tower. So AMF function will handle user equipment as well as radio access network. And this is about user plane function, which I've already mentioned to you about user plane function. Uh, so this side, we have a network exposure function, network repository function, policy control function. This is a unified data management function, UDM. So these are all the various entities present in the 5G system architecture in terms of control plane functionalities. So if you look at the overall aspects, as I mentioned to you, the tower in 5G is called G node B or next generation E node B. So this is what it is, a 4G E node B with the patched new functionalities. That's what NG. So in other words, it's called GNB or NR. We call it as new radio. So that is what all the towers, we can use different terminologies. Please remember, no confusion. When we put NG E node B means E node B is the terminology used in 4G. That's LTE with EPC. When I had NG plus this is a upgrade form of 4G tower. I mean, upgrade from 4G, that is 5G tower. So this is also 5G tower. This is also 5G tower. That is why we mentioned next generation radio access network. So this is user equipment. That's handset. And with respect to control plane, as I mentioned, unified policy function. This is access and management function. Uh, these two are the control plane functionalities with respect to 5G. So I will talk about how this is going to be relating to the various level in terms of protocol stack. So what do you mean by protocol stack process? Why do you need to study about protocol stack? Hello, professors, are you there? Protocol stack, when you say TCP IP stack, normally for the internet access, we follow TCP IP stack. We have physical layer, data link layer, and then network layer, transport layer, application layer. This is what is the flow of the stack. Similarly, in 5G also, we have a protocol stack. So with respect to user level, and this is a user equipment, we will have the functionalities NAS, that is, as I mentioned, non-standalone functionalities, radio resource control, packet data convergence protocol, radio link control, medium access control with respect to L2 layer, physical layer. So these are all the various APIs present in the user equipment. Are you all following process?
Yes, sir.
No. Yeah. So we have a user equipment with respect to APIs, which is connecting user to the network. Network means the very first accessing element is G node B, that is a tower. In the tower also we have a radio resource control, packet data convergence protocol, radio link control, MAC layer, physical layer. So appropriate APIs are linked. So we have a direct linking from user equipment to AMF. That is I've already mentioned about AMF function here. So you see access and mobility function, that is control function present in the control plane. So user from NAS API connects directly to the AMF, which is a important layer in the control function, which is having direct linkage to this. So this is what the understandability in terms of control plane. So if you take user plane, so user, as I said, the same user, in terms of user plane, we have a so-called service and data adaptation protocol. This is a adaptation protocol. So same adaptation protocol functionalities in terms of node B also, G node B. So this is connected. We have a packet data convergence protocol, radio link control, MAC, physical layer. We have appropriate linkage. So if you take, I think as I said, control means signaling. So let's say you and me has to be connected for a video streaming. So that is connecting and serving the video exchange. That is the task between user. But whereas to provide that service, there are so many functionalities happening at the back end. That is what we call it as control function or a signaling messaging. So we have a signaling, that is a C plane, that is AMF. Through the AMF, this is getting coordinated between two users, which handles the different control signal in order to facilitate the exchange of the video service between requested user and offering user. So that is how the system functionality is to be dealt. So this is about radio stack. So as I mentioned already, in terms of RRC, that is radio link control. So what is the functionality of RRC? So especially with respect to RRC, I think morning session professor would have told you about UTRAN. UTRAN means UMTS terrestrial radio access network. That is the 3G tower. From there only we have got E means it's a enhanced neutron. That is what we in short in 5G we call it as new radio. So the radio link resource control of user equipment getting connect with the radio resource control of G node B as well. So this is relating to I think with respect to physical layer, if you talk, we call it as so many resource block. So signaling radio bearers. So to connect the signaling radio bearers, these the API what is present in the UV and the API present in the G node B, that is the tower which is getting connected. So that's what we call it as signaling radio bearers and data radio bearers. So we will have a data level as well as signaling level connectivity. So I think this is how all the sub functionalities. So if you take with respect to RLC, packet data convergence protocol, MAC layer. So this is in terms of if why I'm talking so deeper level, in the sense we have a MAC. This is about upper layer. I think if you see basic computer networks, we say MAC layer has got two functions, L1 and L2. I'm sorry, L1 is physical layer, L2 is MAC layer. MAC layer has got MAC management function and MAC scheduling. If you take with respect to 802.11 wireless LAN, what kind of MAC mechanism followed there? Process Ethernet. What is the MAC mechanism? CSMA CD. Are you all there? Process.
Yes, sir.
Okay. Yeah. So do you know CSMA CD? We cannot use that same CSMA CD what we use for Ethernet for Wi-Fi, because if you go to 802.11 with respect to Wi-Fi, we have to change the access mechanism to CSMA CA, because we have a hidden problem, exposed terminal problem, near problem, far problem. So these are all the four varieties of problem when you move from wired to wireless. So we have a RTS CTS based MAC. That is what CSMA CA we call it as. So likewise here also the MAC functionalities with respect to UE and various user equipment, that is multiplexing. And we have one more important entity. It's called hybrid ARQ. Even in 4G, we have started about hybrid ARQ. Normally, ARQ, where it will be present? ARQ will be present in the transport layer. So there are some of the duties to be done in the transport layer. So now, because of cross-layered approach, the same duties has been taken up in the physical layer itself. It is important that evidence that in physical layer packet checking itself, we can do some of the process, and we can discard if it is not up to the mark. Rather going all the way MAC processing and then going to the network and then going to the transport layer, there you're classifying packet is not good and dropping. Instead, you can do that kind of sensing at the physical layer itself. So that's what we call it as cross-layered approach. So we have that approach already started up in the 4G itself. We have a hybrid ARQ. That is what is present in the as an API. I think this hybrid ARQ will connect to the appropriate function API of the physical layer. So on top of the MAC, we have a radio link control, packet data convergence protocol, service adaptation protocol in terms of scheduling and security related aspects in terms of I think that's why I mentioned physical layer L1 and L2. So this is with respect to user equipment and node B together. This has to be dealt. So if you take with respect to service adaptation layer, which connects user equipment as well as G node B, so which provides mapping of the different QoS level and QoS flow with respect to uplink and downlink. And as I said about we have a signaling as well as data bearers. So related to that, this will handle only data related bearers. So we have a packet data convergence protocol. This is going to take care of serial numbering in terms of fragmentation and header compression, user migration, duplicate identification and recording, routing with respect to retransmission, deciphering and encryption, deciphering at the receiver, encryption at the transmitter. So that is how the PDCP layers given functionalities as I mentioned in the right side. Similarly, we have RLC, that's a radio link control. This will do resegmentation and segmentation. As I said, when we have a huge size of packet, we have to slice it, and each slice number, we should have a serial number. So that is what is segmentation. Reverse processes resegmentation. So in terms of ARQ, automatic repeat requests in case of retransmission. So all these things are the functionalities of RLC, radio link control. So we have a MAC mechanism, uplink scheduling and downlink scheduling are the important role of MAC layer in 5G. And I think it's asymmetric scheduling, because uplink will have a lower capacity than the downlink, because normally downlink has more size. I think that is a asymmetric structure, what I've already told in the yesterday's class. So if you look at with respect to network architecture, this is beyond 4G E node B. As I mentioned, E node B means beyond 4G, and exact G node B, that's a new radio. We have a core network as well as non NAS as well as standalone. Two versions are there, are coexist in this architecture. So this is about core functionalities, as I mentioned about unified data convergence, policy control function, and AF and user unified data management, NRF in terms of a repository function, network exposure function, So these are all the control plane and the user plane in terms of UPF. So this is what about I think all these activities to be coordinated with the and which is connect with the UPF. So this is the architectural framework of core architecture of 5G. So this is what I've just represented in a different form, as I mentioned about these functionalities and mapped to appropriate level in network, and which in turn goes to we have a N1 API, N2 API, and N4 API, N3, N6. So I think in GSM, if you remember, we have a UBIS interface, ABIS, AA interface. Likewise, in network level, we have N1, N2, N3, N4, N5, N6. These are all the APIs. So the functionalities already explained already. So this is about core network functional elements in terms of the 5G. So with respect to user, we have a you know, EM, NS3 broadband. So then,
ஹலோ
hello,
கேக்குதா? ஆ
hello, am I audible? Hello, am I audible?
ஆ nice.
So
Hello.
your voice got cut in the between.
Oh, in between. Okay, I'm sorry. I don't know. Now audible?
Yes, sir.
Yeah. So with respect to this is with respect to core functionalities, and with respect to user, the entire application we can broadly categorize it into enhanced mobile broadband category, and this is a machine type MMTC and ultra reliable low latency category, and accordingly we can said I think we can categorize set of applications. I think yesterday's class also I mentioned about different use cases under EMBB and massive machine type as well as ultra low latency. So this is, I think now coming closer to the concepts what we are going to explore in terms of NS3. With respect to a millimeter wave, we have used the very interesting concept called beam forming. What is beam forming? I think there are many EC professors also there. This is a very important concept in even in 4G. So it is like what we do with respect to beamforming means we write a signal processing algorithm. So that algorithm will determine exact efficient path which takes the user data from base station to the appropriate user. So we may have multiple paths. So if you look at the packets can send in a multiple direction, and it must be choreographed to reach the end user in a predetermined sequence using multi-input, multi-output. We have dozens of antenna. So if you take with respect to either user or a so-called tower, we have a MIMO, multiple input and multiple output, several dozens of antenna, both at the user level as well as tower level. So we have to write a efficient algorithm in such a way that the signal in both the direction, either maybe uplink or down. I think this is the concept. Normally we say beamforming from the tower to the user. So that is what is the very important concept which is adopted in the 5G. That is a beamforming. So I think when you look at with respect to end-to-end simulation, so we are going to have a physical layer. I think this is if you look at with respect to 4G LTE, we have a mobility management entity in terms of control plane, serving gateway and packet gateway in the user plane in 4G itself, and we have a common functionalities in 4G as well as 5G. It is commonly shared, or in other words, I keep making use of the existing 4G the API, RRC, radio resource control, radio link control, packet data convergence protocol. These things are already there in 4G. Even 5G, we reuse them again in the 5G architecture. And there are a lot of tweak happened in the MAC layer and physical layer. So with respect to the support of FR2, FR2, which is a 24 gigahertz to 100 gigahertz range. So the complete full stack, and we can even customize the stack that support is there in the NS3. So that is why I think it is not like any confined frozen architecture. So I mean, as a researcher, you can tweak and understand the various functionalities, and you can bring out better performance. That you can do with respect to the layering, understanding the layering. And if you see the overall end to end, when I say end to end, this may be a remote host. This is a user. So please understand the millimeter wave concept to be adopted in at both user side as well as tower. Tower, which in turn backend goes to serving gateway, packet gateway, and which in turn connect with the remote host. So this is what is the end to end upper layer you should understand. When it comes to millimeter wave, we have a physical layer. This is a medium link layer and IP and TCP UDP. So why I said protocol stack, you should understand these things. So if you look at with respect to physical layer, MAC layer, and other things are we are just like following from IP, TCP, UDP or application. So if you take with respect to physical layer of millimeter wave user equipment as well as E-node B. So if you take with respect to physical layer, we have a array of antenna model. We mean to say MIMO, and we have a beam forming, and we have a millimeter wave propagation loss model. I think yesterday's class, Pradeep sir might have shown some of the outdoor models. Can you name few outdoor propagation model? Hello? Professor, those who are teaching wireless or wireless communication course, you may aware of. There are a lot of
Yeah,
model.
yes, yes. Okumura, sir, Hata.
Yeah, very good, madam. ATA model, Okamura model, and
Yeah, yesterday sir showed how to change the attributes in NS3, like in the
yeah,
codes.
yeah, very good. That's nice. Yeah, that's what I was telling. So, sir has shown and the physical layer parameters
Free
how to
space model, sir.
free space model, yeah, very base model, free space model. We have in cellular a specific outdoor model like ATA, Okamura, Raytheon model. So these are all the popular models are there in outdoor model. So here we have a propagation model, name itself millimeter wave propagation loss model, and we have a my error model. So and this is a multimode spectral channel. I think please try to understand when you are studying about wireless communication, you should really focus on physical and Mac layer. So then when you are a purely a computer science engineer, you may work in terms of leaving these two layer. Normally, the professor's mindset is electronics and electrical people work more, deeper in terms of physical and Mac layer, and computing people they work in terms of routing in IP layer, and they build a lot of applications at the application layer with ML AI driven applications. So please try to understand if you tweak the physical and Mac layer, then only we can bring out the performance in terms of higher data rate and coverage that is possible only because of this physical layer functionalities as well as Mac layer functionality. So that you should be very strong. As I told you, beam farming, how the beam farming works in terms of the E-node B. So we have a 4G, we have a coordinated multi-point. Some of you might have aware those who have a those who are have a closer follow-up with the 4G to 5G. So there we have used QAMP, that is a coordinated multi-point. So femtocell, picocell, a lot of concepts were started in the 4G itself. So this is one such interesting fact, that's a beam farming. So we have a millimeter wave spectral physical layer. So millimeter wave spectral physical layer, these two are the APIs. One goes to the user equipment, other one goes to the E-node B. So when it comes MAC layer, medium access, that is the scheduling of the MAC. We have a millimeter wave UE physical layer. Just see the here millimeter wave UE physical layer connect to the millimeter wave spectral physical layer. That's how these two APIs are connected. Here millimeter wave E-node B. E-node B means, as I mentioned already. So in 4G, E-node B, and this is also got NAS architecture. That's a non-standalone. There are two ways: indigenous as well as non-standalone. So this is not indigenous. This is a non-NSA, non-standalone architecture, which coexists with 4G. That's why we are talking about E-node B. So this is LTE, RLC, AM, UM, and LTE PDCP. This is LTE E-node B RRC. This is LTE E-node B RRC. These are the functionalities in terms of user equipment net device. This is the E-node B net device, and this is the EPC, evaluated packet core. E node B application. This is goes to tunneling protocol. This is the GDP. So this in turn goes to the packet and serving gateway. This in turn goes to the remote host. This is how the NS3 what do you call it, layering wise stack is built. So if you take NS3, we have a SRC Lena that is come under. I think if you remember Lena, it is there in the separate folder in source inside NS 3.38 or 40. So I'll show you all these things in a while. So this is the statistical model people have done the work in terms of the physical layer measurements. So especially New York University, and they have contributed a lot in terms of the physical layer related functionalities. So that's the reason why I have mentioned about it. So they have done a lot of work in terms of the channel in the range from 20 gigahertz to 28 gigahertz to 73 gigahertz. So they have done this physical layer transmitter as well as receiver. That's together we call it as transceiver model, and they've even done the deployment and both the LOS as well as non lineup site. So I hope you understand this is a lineup site and non lineup site. In the they measured the various outage probability. So in their city, they've deployed this model and tested. I think the entire simulation they've done it with NS3 only. That is what the important highlight I just wanted to say here. So this is what is about. Several user equipment. This 4 user equipment with the base station, and we have a uplink and downlink scheduling. So with respect to dynamic TDD, that's a time division duplexing with TTI, that's a variable transmission time interval, and the short subframe. I hope you understand with respect to 4G, we have only single carrier. So 5G only we have a multiple subcarrier. That's why we need to talk about so-called subcarrier spacing. So that is why we have a numerology concept come into picture. Have you heard about numerology in 5G process? Those who are working with the physical layer, you may be knowing about numerology in physical layer. Uh, Process, are you all there? Hello? At least say yes or no, please, process.
Yes, sir. Yes, sir.
So
Yes, sir.
terminology means, as I say, UE user recommend, BS base station. These are all terminology. Numerology means 2 power mu into 15 kilohertz. That is a standard term. What we follow numerology. Mu may be from 0 to 6. Mu, when I say mu equal to 0, 0 into 15. That is subcarrier spacing is 15 kilohertz. So if I put mu equal to 1, 2 power 1, 2 into 15 kilohertz, that is 30 kilohertz is subcarrier. So likewise, you can have a range from 0 to 6. So you will have a different subcarrier spacing. Why I say subcarrier spacing? Because of OFDM. Are you all following?
Yes, sir.
Yeah.
Yes,
So
sir.
because of OFDM, we know orthogonal frequency division multiple access. Thanks to OFDM, that is the reason why we have a such high data rate packing is possible. So that is why I say and 5G numerology OFDM with time division multiple access with carrier spacing. So to have a better radio utilization and a low latency, that is what is the outcome. What we wanted to expect if you do proper uplink and downlink scheduling in the MAC layer. So this is about so I think we have varied the various TTI, that is a variable TTI as well as fixed TTI, and we have measured the performance of many UEs with a single base station. So with respect to low rate, this is with respect to high rate. I hope you understand with respect to data rate. And this is what is AMC with channel quality indication CQI with 1 gigahertz millimeter wave. And we have measured about with respect to AWGN channel as well as phosphating channel. So with both, we have compared the performance. So this is about, I think before I go to the user level demo, I will go to, I think we have a lot of scenario, 1, 2, 3, 4, 5. I think I made some scenarios, and these are all the things is there in the form of NS3 core. When you say NS3 core, we have all the core elements, and we have a TCP/IP stack and applications, various applications we can build. So this is about if you see as I mentioned, non-standalone 5G millimeter wave. Are you all following process?
Yes, sir.
Yes, sir.
Yeah. Yeah, thanks. At least few are responding. And this is a user equipment. And as I mentioned about user equipment, UE, RLC, MAC, physical layer, MAC on top, RLC. So this is a E node B LTE, and this is a millimeter wave E node B. So that means this is a 5G. This is a 4G. This is a 5G. We have a 5G RLC, 5G MAC, 5G physical layer. So on top, the MME, but whereas in 5G, we have a 5GC. This is MMV serving gateway and a packet gateway. This is about EPC. I think why I am focusing EPC many times means, so when you talk about millimeter wave, you will be seeing non-standalone 5G millimeter wave. So there we will see EPC terms also. So RRC procedure, SNIR based initial access, secondary cell handover, fast switching between radio access technologies, or X2 seamless handover. So I think I have a demo in handover also with respect to 5G Lena. So two different demos I will show you in NS3. So one with the millimeter wave, other one with the Lena, 5G Lena. So I will show you. So I think now I want you to use Pradeep sir have shared the uh, image. Have you all extracted the rare file what he has shared? Process?
Yes, sir.
Yeah. Uh, I think at least whoever extracted, please respond. I think I have already had another VM image that was there here. Don't worry. In your case, if you have only one with so-called virtual box, you may be running this name of the VM image is 5G. That is what you must be loaded and started. So in that way, I have this is the 5G VM what is running in my machine on top of Windows. Is this fine? Do you all
Yes,
got
sir.
this level?
Yes.
Yes. If you are in this level, so you can put Control Alt T. So where you will be reaching to this terminal. So Control Shift Plus will take you to enlarge the what do you call that font. So now currently you are here. When you put PWD, so you will come to know about current location. So I put CD NS all in one 3 point
NS3 millimeter.
yeah NS all in one millimeter wave. So here itself you can put LS. You will have a there is a separate folder NS3 millimeter wave new handover. So you go to that. So if you put LS, you have a so-called folder relating to millimeter wave, EPC, simple. So I think this is all PK files what you have generated, and the source code relating to this, it's there inside the example CD examples. So, you have a lot of model inside this. So inside this you have a tutorials also, but I will not go to that tutorials now. So you can explore the basic tutorials on your own with respect to this examples. Now I am currently inside a new handover. So in here we have something called SRC. Can you see SRC folder? If you want, I'll just clear this. I'll show you currently you need to go to this location. That's what my point. So after running this VM, straight away go to CD. So it will when you put it will take you up to home Pradeep Kumar, up to this home location. From there you directly go to NS3 millimeter wave and you hand over. So here you have something called SRC CD SRC. So if you go here, you have the folder called millimeter wave. Can you see lot of folders are there? All are applications. There are those who are wants to work with antenna. As I said, beam farming, a lot of other stuff in physical layer. You can work here. Those who want to work a lot of routing, AODV. Those who want to work with LTE folders there inside. SR inside LTE, we have examples. A lot of examples are there. You can take all these things to the scratch folder and you can work a lot. So that is why we are explaining this much. So we have millimeter wave is one such relating to 5G. Those who want to work a lot in terms of IoT related application, we have a 6LoWPAN, that is a 6LoWPAN. Those who want to work with ITS, Intelligent Transportation System, V2V, V2I, V2X, there is a option called Wave here. Those who want to work with the Wi-Fi, that's WLAN. There are a lot of 802.11 what do you call variants, that is AZ and M, lot of things. With respect to 802.16 is the WiMAX. So WiMAX, when you take 2020, during the time there was a big competition between LTE versus WiMAX. So yeah, WiMAX has got a lot of support as equal like LTE, but WiMAX, the LTE only won in the competition. The reason why is LTE has got a lot of backward compatibility. So so many service provider, they can easily migrate their tower to 3G to 4G. That is why LTE become a successful candidate than WiMAX. So WiMAX, you have to completely erect a new tower, and in terms of operational cost, you have to collect only from user. So per bit cost is so huge in WiMAX. So but it supports both line of sight and non-line of sight. So this may be a prominent candidate. You can use this as a backhaul. So one center point of the village, you can install WiMAX tower. Entire village, you may get a coverage. So that sort of support. It gives 8 kilometer non-line of sight. I'm sorry, non-line of sight and line of sight with 15-kilometer coverage. That is such a powerful entity. So you have a LR, low power WPAN, and a lot of applications are there. You can work. Now I go to millimeter CD, millimeter wave. Inside you have a examples. Inside this you can see a lot of applications. So with respect to SRC millimeter wave examples, so these are all the millimeter wave related. You have a simple EPC. So as I said, millimeter wave simple EPC value to packet code. That file I'll just take from here to the scratch location. I will be executing that from there. So why I take it to the scratch means, in the scratch you can develop a lot of things. So because I don't want it to update modify anything in the existing base code, I will be going. I've already taken that into SRC. There is a folder called scratch. CD NS3 NS3 millimeter wave. Inside this LS, we have a scratch. Can you see scratch? This, so we go to the scratch ALS. So I think I've shown you from where I've taken the millimeter wave simple EPC. Likewise, we have 10 more source files are available inside a SRC. The same inside the SRC, we have a millimeter wave. So from there, I've copied and I moved to scratch. So you can do like a GUI based also. So I'll show you GUI based how I'm doing. So go double click and so you have a separate folder called
mmWave.
NMWave. NMWave. Inside this we have a SRC. We have a folder called millimeter wave. Millimeter wave. Inside a millimeter wave we have examples. So you can see, as I mentioned, can you see? You can right click millimeter wave EPC. Millimeter wave. Can anyone tell? Yeah, this millimeter wave EPC. This is what you can put copy. As I said, see copy. You can take like this and you can come back inside a scratch. You can paste it here. I can do, but I've done some edit So you can do this also. You can replace. You can do replace. So I've just replaced. Now I will go there. I'm going to execute. What is the command to execute? Sir already told the base code, right? So you always execution must be in the so-called main location. That is PWD. You need to go to CD, NS, all in one. Millimeter wave. You need to go to millimeter wave. CD, NS3. Here dot slash NS3 run. What is the name of the file? Inside the scratch millimeter wave dot cc, enter. It will compile. So it's showing some warning that you don't worry about mobility model. So it is got executed when you want. I think we have developed a code inside. We have written a what do you call a script to store the activities in XML file. So I'll just open up and show you the code. Gedit. Can you see the code process?
Yes, sir.
So this is the template of the code. So the required header files, as I mentioned, I think if you go to NS3 location, this is the location. If you remember inside a home, NS all in one, this is the bare metal inside a 3.36. So you have a contrib, dog, core, utilities, scratch. So this is the bare metal. So all the includes whatever I've mentioned it will be referred from appropriate folder NS3 all in one NS3 3.38 up to that. From there application command config internet. I think sir has said already network side network interface node means what, all these things, the basics functions sir has explained already in the preliminary session, right? So now specific to this we have a millimeter wave helper, millimeter wave point to point EPC, and mobility model.h point to point helper. These are all the header files we have included. So this works based on C++, that is object oriented principle. It supports very strong namespace, the NS3. So name here millimeter wave is the folder what we refer. So I think EPC example inside this. So you can see what we are doing. This is the simple example between user equipment to the unode B. So one user equipment to the unode B is a 10-meter range. Another user 2 to the unode B is 150 meter. Are you all following? We are fixing the min and max two ranges. So your UV can run from the distance minimum 10 to 150-meter distance. So you have enabled the hybrid ARQ. Are you all following?
Yes, sir.
Yeah, hybrid ARQ enabled, right? So these are all the settings we are just starting. And when if you can see the from user equipment number of unode B and number of user per unode B, you may have a set of unode Bs also. So these are all the command prompt based input you can take, and you can parse and process the argument count and values. And when it comes to millimeter wave helper object and point to point object. So I think if you look at with respect to node container is the class. So we create object for a remote host. I've told you remote host, that's where the application is present. So from there to you call it as a EPC, then to the E node B, then to the user. That's how it has to, the packet has to travel. So we have a point-to-point data rate about 100 gigabits per second. So we have configured for a 5G data rate support. So this is what we have configured the IPv4 base packet. So this is in terms of number of E node Bs, E node B nodes, number of E node B, number of user equipment. So we just get all these things and we configure. This is about mobility model. So this is a UV mobility model, user mobility model pattern. So you might have heard about random mobility, random walk, random waypoint, so many Manhattan mobility, a lot of things. So here we call it as constant position mobility model. So the name of the mobility model, what we followed here for the user equipment. So I think only user will move. So G node B is a fixed tower. So that is not one end only is mobility, other end is not going to, that is a fixed node. So this is a sample. So I think we ran and already we ran this simple code. Now I'll show you with GUI. I think uh, now this is generated a so-called XML file. So where it is generated and where it is available and how to process that script and to animate with animator, there is a net animator, and to write the performance of this using script and how to take the performance values in terms of graph, and how to represent graphically when you are a researcher, when you wanted to publish your work in terms of paper. So all these things, writing script and how to visualize with a net animator tools. So all these things will be explained by Pradeep sir in a short while. So I will be handing over to Pradeep sir. Sir will continue from here. Thank you.
Okay, sir.
Is it visible?
Is my screen visible, ma'am?
Yes,
Friends?
sir.
Yes,
Yes,
sir.
sir.
Okay. So now, yesterday we were discussing about one third slide, which is very important for researchers. If you are planning to do research, these tools, okay, the tools for NS3. So one tool is trace metrics, another tool is NetAnim, third tool is Wireshark. We'll be seeing these three tools in 5G today. Okay, this is not only for 5G, this is for every, I mean, yeah, all the networks, whatever research you do, these three things, these four things or five things, PCAP. So these things are mandatory for this NS3. Okay, so I'll show you all these five things in this 5G simulation here. Okay, so having said that, if you know the technology of 5G and if you are working on it, then how do we express this thing about? Okay, now I'll just go back to the slide here. Now this is the code. Okay, so this is the source code mmWave simple -epc.cc. Okay, now just let me close it. As we have seen that in the scratch folder, I should have this file. So this is the file mmWave simple epc.cc. Now what I do is I'll just make a fresh copy from the source mmWave examples mmWave simple epc.cc space dot. When I do that, it is copied now. Now gedit mmWave this thing. Now this is the file that we are planning now. Okay, so we can see that at the end here we have something called as enable packet capture all. That means we are enabling the packet capture everything, and we make this name as mmWave EPC simple. Now what I do is I'll use like this 5G mmWave. I give the name as 5G mmWave. Okay, so I will be getting all the files relevant to this 5G mmWave. So this is on packet capture. So PCAP is packet capture. We can able to generate a simulation. Okay. Now one more thing is I want to add NetAnim. Okay. So let me use to add network animation. So we have to add one header file called as include NS3/netanim hyphen module.h. So this is the network animation header file that we need to add before we add the coding here. Now come to the end of this program, before the simulator stop. So before the run or the stop, here you can use something like this. All the source codes I will be sharing you as well. Okay, it is already there, but whatever modification I did, that also I will be sharing it with you in the Google Drive, what I have sent in the WhatsApp group, so that all of you can able to download the files, whatever relevant to this FTP. Okay, now adding the animation relevant codes, animation relevant codes. Okay, now the line here is the name of the class is animation interface anim. The name of the file is I use something else 5G even WMM wave.xml file, because all the source codes will be, I mean all the coordinates parameters will be sent to this animation interface, so that we can able to have the animation file. Okay, so this animation this is mainly for NetAnim. The following line creates an XML file for demonstrating in NetAnim software. NetAnim software is, you can see the software name is N is capital letter and A is capital letter, N and A. They are not small letters. N is uppercase and A is uppercase. This is the NetAnim software. So we will be opening this XML file in the NetAnim software for demonstrate, for seeing the demo of our network, whatever we did. Okay. So this is on network animation. So first thing what we do is, as per my presentation here, NetAnim. This is what we are going to see now, NetAnim. Other three things also we will see one after the other. First we will go into the NetAnim. Okay, right. So now I'm just did the modification. Now I'll run the example. So the example is I can run from this NS3 run scratch mmWave simple hyphen epc.cc. So once I run it, if at all any error there, the error will be pointed out that. If no errors are there, then it will be compiled. Okay. So now why this warning shows is all the nodes in the 5G is having constant position. So for the constant position, it is asking for the location coordinates, which coordinates you want to make the nodes to sit. That's why this warning. But anyway, neglect the warning. Warning is not needed for us. Neglect the warning. Now you can see that when I use the file here, I can see 5G underscore mmWave.xml. You can see the file got created. So this is the 5G underscore mmWave.xml file which got created. Okay. Now this file we are going to open it and then see how the demo works for us. Apart from that, we have some packet capture file. You can see PCAP, 0 to 2 PCAP, 0 to 3 PCAP, 1 to 1 PCAP, 2 to 1 PCAP, 3 to 2, 3 to 3. Like that, we have various packet capture files. We got it. And we have some trace files also. So you will upload RLC statistics, upload PHP transmission trace, upload PDCP statistics. Like that, we got. And we got one more thing is ENV scheduled allocation traces also we got. So likewise, we got so many other text file from this example. Okay. Now first let us go into this network animation. So we are going for the network animation. Okay. Now in the network animation, you can see I have just given an example how we can do is this slide also I will be sharing it. Okay. So how do we do is this is how the way we do the NetAnim. Okay. So animation interface, the name of the file is .xml. Then after that, open NetAnim and open the XML file. That will be done. Okay. So let me go into opening the XML file. So in case if you want to try freshly, I create a new terminal. Okay. I open a new terminal. So the new terminal. So NetAnim is there in NS all-in-one 3.38. Here only we have a NetAnim. The code, this is the line where we can write. Okay. So NS all-in-one 3.38 / NetAnim 3.109. This is the version. Okay. Once you do that, click ls, type ls, and then see there is one file in green color. We show it is a NetAnim. You can see that this is the name of the software. N is in uppercase and A is in uppercase. Both are in uppercase letters. So what do I do is I come back here, clear the screen, /NetAnim. Okay. I can use N caps, A caps. So please always remember this N and A will be uppercase letters and it should not be small n and small a. Okay. So now once it is there, a window gets opened. You can see this is the net animation window. It gets opened. Now in the top left, you can see there is one open icon there, and there is a refresh reset icon there, and we have statistics and we have packets. So all the information will be coming here. So now my purpose is I want to open the 5G mmWave XML file. So click it, click open, then go to our folder where it got created. So NS3 mmWave new handover. Inside that, we have 5G underscore mmWave. So I created one file called as 5G underscore mmWave. Open it. So once you open it, you can see that the nodes are there. So maybe for you, you may or may not see. I will make the fonts to the nodes to be bigger. Now can you see there are 5 nodes? Okay. So 5 nodes as per the source code. Okay. As per the source code, how do we know it is 5 nodes? I'll show you that. Scratch mmWave. So what are the 5 nodes is, you can see in the source code, can see create one. So remote host container, there is one remote host container, and any other node here?
Professor, a small doubt, Professor.
Yes, sir.
That node will be static or dynamic?
Which node, sir? All are static only.
Static only. Okay.
Because we used constant position mobility model.
Yeah, constant position. Yeah. Oh,
see, for the ENB mobility also we use constant position, and for UE mobility also we use the constant position.
Constant position. Yes.
But in case if you want to make it move, you can use random waypoint mobility model or random walk 2D mobility model. Any mobility model you can try out.
Okay, Professor.
You can modify the code as per the mobility model what you want to use. Okay.
Okay, Professor. Okay.
So now we can see the number of ENB, number of UE. So here we have one remote base station. A remote host is one node. Create of one means one node, and UE nodes and ENB nodes. So number of ENB, number of UE. You can see in the declaration what we declared is a number of ENB is 1 and number of UE is 1. But here it shows that how many UE, each UE, one UE per E node B starts a flow. That means one user equipment per one E node B. So that's how the way it starts, and we have one remote host also. Okay. So it also starts yet another flow between each UE pair. So this is how the way it starts. Now, as per this demonstration, we have 5 nodes here. Now I just go for this is the play icon. When I use the play icon, the total simulation time is 2 seconds. Okay, so the simulation is running slowly. I can able to increase the simulation slightly fast. You can see here. Maybe we can. You can see. So this is the, actual simulation, how your animation works for your 5G networking. So this using NetAnim, you can able to try. So NetAnim comes along with NS3, but in the VM, I have given 2 versions of NS3, one for 6G, one for 5G. So in the 6G model, we have the NetAnim software installed. So you can try out this. I will give in the handout how to run this NetAnim also. I'll give it in the handout, so that after this FTP gets over, if you want to try out also, the handout will be handy to you, so that you can able to do it as it is given in the handout. So this is the simulation. So if I want to make speed up, I can do the speeding up here by dragging this fast and slow. You can drag this. Okay. So this is the actual 5G network. Okay. But anyway, being a research, if you want to do some research, only just checking this animation will give you a feel that, okay, there are some packet transmissions are there. All the nodes are actively participating. Now what next? How do I analyze my results? This is where our work lies upon. So for that, let me close this window, because we have seen it, how our simulator is working. Now I will come to the next thing here is this concept here. What we call is trace metrics. We have trace metrics, we have ASCII trace metrics. So we have this, these 2 things will be needed for us, and the packet capture also. We will see packet capture next. We will see these 2 things. Okay. So now again I come back here. Now in the same source code, again I come to the stop. the last line before the stop here. So after the animation interface, ASCII tracing below. Okay. So the name of the class is ASCII trace helper. The code is ASCII. I can give you like this. So this is the ASCII trace helper. So that means I create an object called as ASCII. Now this ASCII will be enabling only for the channel. Okay. So generally in any program you can use the channel name. So the name of the channel, you search for the channel name. So we have channel name is P2PH. This is the variable name that we got. That is point-to-point helper P2PH. Just copy this P2PH and come back here to the end. So now what I do is Control V dot enable ASCII all. This is the function. Okay, so enable ASCII all, then ASCII dot create file stream. So since I already know this function, I'm just writing. But in case if you want to do that, you can make it, just copy paste these two lines to enable ASCII trace in your simulation. Now here I use 5G underscore mmWave dot tr. So now this will be in the trace file. Okay. So I will be establishing the 5G underscore mmWave dot tr file for recording all my trace information in this particular file. So whatever happened in the channel, the point-to-point channel, whatever is recorded, everything will be captured and then will be written over this trace file. Okay. Now this is what this ASCII trace. Okay, these following two lines. So in any networks in NS3, just copy these two lines. Only thing is you have to find out the channel variable name. What is the name of the variable? In this case, it is P2PH. In your simulation, it can be any number, any name that you copy it. Okay. Now, since I do the modification, I go back and run the simulation again. Okay. So /NS3 run scratch mmWave and hyphen simple .exe. Once I do this, okay, still the simulation is going on. Yes, the simulation is done. Now we can see one trace file, namely, if you can see 5G underscore mmWave dot tr file. The trace file is got created. Now just open this trace file, 5G underscore mmWave dot tr. Let's see this file. Such a long set number of lines in this file is. I think the memory is not enough. Anyway, I close this file. Better I just show you the number of lines. The total number of line is 1,72,831 lines in this particular file. So that much amount of trace information just for 2-second simulation. Just the simulation is only for 2 seconds. Now, how do I process this? How do I process this trace file? Okay. So this trace file can be executed by a software called as trace metrics. That also I included in this software. Okay. Now again I open another terminal. Type ls. You can see there is one folder called as trace metrics. Can you see that? So trace metrics hyphen 1.4.0. So there is one folder here. This also I have just enabled. I have just installed in the VM. So if you are working on 5G and 6G, and if you are working on some flying networks, drones, then in NS3 on any module, if you work on, then this VM, if you have it, it contains everything. So not a single installation is needed. Everything we can able to install this here. Now, how do I run this? Is open, go to the tracemetrics.1.4.0, then type ls. We have one jar file. That's a Java file. Execute this Java space -jar tracemetrics.jar. This is the command. Anyway, how to run this also, I'll give it in the handout on how to open trace metrics. Everything will be there in the handout. Okay. So now once you open it, a window gets opened. So this is the trace matrix, a trace analyzer for NS3. File, open, choose file. So choose the file. Now go back to the mmWave, and here we have 5G mmWave.tr. This is the file, we open it, just open it. So once it is open we see that what is size is, the total size of the file is 88 MB, slightly bigger size, and execute analysis. Once you execute analysis, based on the size of the file, the time will be taken. Suppose if this progress window is hanging, that means something wrong in your trace file. You can try with some other method. Okay. Now see that these are the number of lines in the file, how many enqueued packets, sent packet, received packets, everything there. How many nodes are there? Totally there are 4 nodes are there. And about each node, it will be telling you each node what is the throughput. You can see what is the throughput of one particular file, number of bytes. And for node number 2, what is the throughput? For node number 1, what is the throughput? And for node number 0, what is the throughput? Like that, it will be showing you for all the files. Now, in case if you want to get everything in a single file, then you can get this line here. Now, this is what the number of throughputs here in this particular file. Okay. So you will be getting the throughput values just available here. Okay. So here, this is the way you can able to find out the throughput. So here 1.55 into finally here 10 power 7 and 1.45 into 10 power 7. Here 54, and here it is 0 and 1 into 10 power 7, and here it is 961440, and here it is 540740. So this is the throughput and goodput. So in case if you want to copy this, Control C, just select this and open any editor window. Just open the editor window and then paste it. You can directly paste like this. Okay. So this way you can, instead of E7, you can use E7 here. It means the 10 power 7. Here this is also 10 power 7. And here this is also 10 power 7. So node number 1 does not have any participation. Just it is 54.5 is throughput and 0 is the goodput. Okay. So this is just for 2 seconds of simulation. Okay. Right, fine. So now I got the throughput here. So let me delete the goodput. Let me not go into the goodput now. So this I delete it. Okay. So instead of 10 power 7, I can say that 1, 2, 3, 4, 5, 6, 7. Okay, now here this is okay. So this 54 also node number 1 also I delete. And here it is. I think this is 6, no, 60. So there is one more 0, and here there is one more 0. So this is for throughput. THRO, THRU, throughput. I just make it as throughput. Okay, I'm just storing this. This is for 2 seconds simulation. Okay, now this is done in this. Now next thing is little result. We have results also, packet throughput per delay also we can able to check it, and the streams also. Since it is UDP, I can able to check the streams of UDP. Okay, so this is on trace matrix for 2 seconds. Now what I do is, again I go back to the program, CD NS3, because this is how the way we do our research. Gedit, scratch, mmWave. Here now what I do is, here I go back here. Here all the file, instead of 5G mmWave, I will change it to 5G 1 second. 5G 1 second. I am going to reduce the simulation time to 1 second. Similarly, this also 5G 1 second. Okay, and the packet capture also I make 5G 1 second. For 1 second what happened, for 2 seconds what happened. That's what I am going to do here. Okay, so other things I just leave it as it is. Only one thing is I am going to do this command line. You can see sim time is there. Sim time, total duration of the simulation in seconds is 2 seconds is there. I am going to have 1 second. Or 1.5, 2. 3 things I can do the simulation. Now I am going for sim time here. So let me run the code here. /NS3 run. Now I use double quotes, scratch, mmWave, double hyphen, sim time equal to 1. Now using one file here. Now one here. Okay. Now I'll just run it. Now already whatever I had done in the previous case was 2 seconds. Now here it is simulation time is only 1 second. I am just sending the runtime value for one unit, for one time unit. Okay. Okay. So now again I'll go back here. Here very easily 1.5 seconds. I can use 1.5s. Similarly, this also will make 1.5s. This also will make 1.5s. Okay. So only the 3 locations I can tell. Now it is 1.5 means 1.5. Okay, understand that it is 1.5. Now I'll run it here instead of here 1.5. So sim time is 1.5. Okay. So now 1.5. Now I will just process the trace files from through ASCII trace matrix. So please remember, ASCII trace matrix is not specific to 5G. It is specific to NS3. Any network you take, be it a wireless network or a wired network or IoT network, 6LoWPAN, whatever you take, the same procedure will follow. But only thing is the ASCII trace matrix will work only on the channel, not on the nodes. Don't give the node variable. You have to give only the channel variable. Okay. Okay. Now you can see here, I have so many files ready. 5G 15 TR, 5G 1S TR. So we have 1.5 seconds and this TR. Now again, I go back to my trace matrix. CD trace matrix, Java space -jar trace matrix .jar. So once I do that, the window gets opened. File open. Now here I will go inside this. I have now 1 second. First, let me go with 1 second. Open, execute analysis. So since it is 1 second, the processing time here is only 6 seconds. For 2 seconds, it took 11 seconds. Now it is only 6 seconds. The number of lines also you can see only 81,000 lines. Okay. Now I'll come back to throughput. So this is the throughput what I get. Okay. I just copy this here and I'll come back here and throughput. I'll paste it here. Okay. The number 1 we have not used it. 023. So here what I did is 146985. This I deleted. And this I deleted. Okay. So these are the 4 lines. So Control X, I put 1 is here. Control X. Control X. Okay. Right. So first column is 0 is the node number 0, 2, 3. Second column is 1 second and third column is 2 seconds. Now 1.5 second also I have. Now I close this window again or file open, choose file, open the 1.5 second also. Execute analysis. So do the simulation once, do everything, then you check it. Okay, now copy this and bring back here. Here, number 1, you remove it. So 0 is 1.5 second. 70 na 1529184. Okay, this is correct. Then I delete this, you delete this, you delete. Now Control X. Okay, now Control X, Control V, Control X. Okay, so now I got all the throughput is ready. The name of the file is through through. Okay, so now I'll run one set terminal PDF, set output 5G underscore through dot PDF. So I'm going for PDF throughput here, set title throughput of ENBs in 5G networks. Okay, so set X label is node numbers. node numbers and set y label is y label is throughput in BPS, bits per second. Okay. In case if you want to convert it to kbps also, you can able to by reduce the 1000 there. Okay. Now let's say we go with the kbps. Okay. Now I will put 5g.plt. PLT is plot file 5g.plt. Now my thing is plot. Now I want to use, so column number is 1 second now. So 1 second. Sorry, this is node number 0. 1 second, 2 second, and 3 second. Okay, 1.5 and 2, and this is for node number 0, 2, 3. Okay, x-axis is here. It is slightly it will be different. Anyway, fine. 0, 2, 3. Okay. So now plot thru now file extension using 1:2 with lines title 1 second. 1 second sim time, comma. I will just copy from here. Control C, Control V, Control V. So here 1:3 here 1:3 with the line title 1.5 seconds. Sim time, and here 1:4 with the lines title on 2 seconds. 2 seconds sim time. Okay, so done my GNU plot. Now I will go back to the, my terminal. Here I have these files, 5GPLT and true, these two only. Okay, so GNU plot 5G underscore dot plt. If I run it, the file is running, and ls if you type the throughput, you can see the file name is 5G underscore through dot pdf. Now go to the terminal, go to the open the file. Let's see and how it came. Yes, this is my throughput. So this node number 0, how the throughput for 1 second, 1.5 and 2 seconds, and for node number 1 and for node number 2. So node number 3 we don't have. Yes, node 0, node 2, and node 3. Node 1 is not there. Okay. Now this is the simulation time: 1 second, 1.5 second, and 2 seconds for the ENBs in 5G networks. Okay. So this, like this example, you can able to try all the 5G networks in your simulation. Okay. So this is the way actually we do our result analysis on this throughput. Just I did only the throughput here, and there are other parameters also we can able to check upon. Okay. So any queries, friends, so far, or any doubts?
Professor, what is the other metrics apart from this?
Okay, so I'll just tell you that. See, now other metrics here is
especially any 5G cases metrics that
5G case metrics. We need to check it. So actually, flow monitor is one there. Maybe tomorrow I may be showing you for 6G. That time I can introduce this thing. And Wireshark is there. Actually, this I'm just showing on the network aspect of it. So networking aspect of it, how we allocate the packets and how we measure the throughput, that thing. But in the 5G allocation point of view, I'll just show you that. Here, you can see here, there are some packets now. So these packet caps are also based on networking. Now I'll come to these packets. Okay. So we have this the ENB scheduled allocation traces. So ENB scheduled allocation. So this is relevant to 5G. Okay. So this thing is relevant to 5G. You can see here the frames the subframes, slot, RNTA, first SIM, num SIM, type, TDD mode, return exnum, and CCAD. So this is what the ENV statistics of your network, of your 5G, this simple mmWave. Okay. So using this, you can able to analyze your 5G parameters. Okay. So this is one. Next thing is DLP, DL physical transmission and physical layer transmission, DL RLC status, and these three files. These three files you can see. Okay, so this thing you can see the standard deviation, minimum and the maximum. Then this PDU size and number of PDUs, RX bytes, delay, standard deviation for delay, and cell ID, IMSC, RNTA. So everything will be available here in this 5G. For every time you do that, this value will be getting updated. But what I did is only this is the last one is 1.5 seconds. So whatever is available is the simulation time is for 1.5 seconds. You can see the starting is 1.25, the ending is 1.5. And 1 to 1.25, 0.75 to 1, 0.5 to 0.75, 0.25 to 0.5. Like this it goes. Similarly, physical layer transmission is like this. This is the physical layer transmission, and this is the RLC statistics. So this way you can able to analyze the 5G related information. Okay. So networking side also you can do the analysis, and 5G communication side also you can do the analysis. Now whatever I did is only on the constant position mobility model. In case if you want to try out any other mobility model also, you can able to try that. Okay. So I think so this way we can able to do the analysis of all our files here. Okay. So not only that, suppose let's say I am a new person who is coming now. I want to check how is mmWave works. So now I just go and check all the files here. These are the files available here. So mmWave with simple EPC we have done it. Now let's say I want to go with the mmWave simple with IP version 6. In that case, you can go like this. Or mmWave TCP building example, or mmWave TCP example. Let's say I want to go this example, mmWave TCP example. Now let's say mmWave TCP example. I'll go 1, 2, 3, scratch. I'm just moving to the scratch folder. Okay. Now let me run it here. $NS3 run scratch mmWave TCP. I have not checked what is the code inside, but this is the first time I'm just trying. Okay, so this is on mmWave TCP with I think the machine get hanged, I suppose. Okay. I think the TCP get hanged. Hanged. So maybe the memory is not sufficient. Maybe that may be one reason, because I have just given only 2 GB of RAM for this VM. So that could be one reason that it is not sufficient. I think it is not coming.
Professor, one more doubt, sir.
Yes, sir.
Professor, we are running for one network, right?
Ah.
Is it possible to do an heterogeneous network? simulation?
Heterogeneous means what do you mean?
It's IoT and as well as the mmWave, the collaboration.
It should be done because see in IoT generally in NS3 the main problem with IoT is just wait, this is hanged. Maybe I'll just show you in my Windows here. I have Windows, I have installed Windows. So I have something I showed you now, WSL. WSL is Windows Subsystem for Linux. I can use Windows command prompt. Within that I can use Linux. See? So here I have just used Linux NS 3.40. See, here I have one thing called a 6-low-pan. You can see this is the only thing available in IoT as far as NS3 concerned. This is the only thing available in NS3 about IoT is 6-low-pan. Okay. So ideologically, 6-low-pan and the mmWave have to work together. But I have not tried it. Given 5G, 6G, 5G I have not tried it. I tried only recently 6G. But 6-low-pan I tried it for some of my work. So it should work. But 6-low-pan is by default there with the NS3 package itself. But 5G and 6G are third-party developed. Means some like you and me, someone developed this package from some university and then they host the source code free of cost. That's how they do. But if you want to tune it, we can able to run it. So this is the only thing available in NS3 for IoT. So low rate WPAN and low rate WPAN example and mesh thing and 6-low-pan. So these are the some examples available for NS3. Okay. So this is the main issue in this, but it should work because that's how the way the architecture of NS3 says that it should support the heterogeneous network connectivity.
Okay.
Still it's not, and I'll close it and then I restart. Yeah. So any other queries, friends? And one more thing is maybe after the VM I'll just show you. And so we have what we have seen so far is, so number one is we have already tried yesterday on MANET routing compare. For that I just preparing one handout. Number two is today we have done mmWave. See, actually what happens is if you are a professor and we cannot devote our time on learning these things. But in case if you want to make some work out of this, maybe you ask your students, your PG students, PG scholars or scholars to work on it and then ask them to write a report or do some experimentation, analysis, all these things. Because usually a faculty wanted to learn these stuffs, they have to invest more amount of time. So better that you can give it to the devote it to the BTech student, undergraduate or postgraduate students to do some small simulations for your networking course, for your 5G course, or some mobile computing course. So for that you can give so that the work can be compiled and given by the students. So in so the second thing what we have seen is mmWave with the simple EPC, EPC.cc. This we have seen. But under that we have seen the modules called as trace metrics. Then we have seen netanim. Then we can see packet capture now, PCAP, or otherwise we can say Wireshark. This also we can see. So these are the three things that we have tried it. In the ASCII trace, we have used ASCII trace help. ASCII trace help. Okay. So netanim. So among the very powerful software is here is Flow Monitor. This is one of the powerful software that NS3 gives. It divides your packet into number of flows, and for each flow, it handles the delay, throughput, all these things in the networking. So maybe tomorrow I'll just show you on this flow monitor how the flow monitor can be tuned, because slightly different tuning is there. Again, you need not understand or remember how a flow monitor works. Just copy paste the flow monitor relevant code, give the name of the XML file, everything else NS3 handle on its own. You need not struggle for that. So this is what we have done for the second experiment. Tomorrow we will see on 6G. Generally we call as a Terra simulator. So this is one thing. As of now, only 6G simulator available is the Terra sim. If you want to work on 6G, you need to rely upon only on this simulator. Maybe some test beds are available, but they are not in the market now for 6G. Okay. So number 4 is flying ad hoc networks. We will be seeing last day flying ad hoc networks using NS3 with Gauss-Markov mobility model. Gauss-Markov mobility model. Actually, one of my scholars is working in this area, and we have already communicated one paper. So that's why I'm just giving away this. But we have used some more models. We have developed our own model based on Gauss-Markov. Anyway, I don't reveal that now. We have already modified the model also. So, but I'll show you the existing Gauss-Markov model, how we can use flying networks. And we use a net simulator also. Net simulator as well. This also will be seeing it. Okay. Maybe for 5G also I can show you net simulator, but I have not tried it. How this will work. Maybe I'll just open my virtual box. Starting. So in the meantime, if you have any queries, you can give it in the chat box so that if I know that I can help you out. No. Yeah. Okay, so now you can see here. Now this is how the way the net simulator works. But this I will be showing you. Okay, so this is my net simulator platform. So you can see here, this is the 3-dimensional platform where I can able to set my nodes, or I can able to set my drones here. I can make it to fly my drones, or I can make my drones to run, or I can make my vehicular nodes to run. Everything I can able to do. Maybe 5G also we can do, I think. But I have tried on drone simulations, but I have not tried it on this. This we will be seeing on day number 5. So variety of options we are just giving you away, and how see majority of the time we get the source code freely, because now the chat GPT and other things comes into it's there in the market. We need not struggle for the source code. So source codes are already available free of cost. Only thing is how to analyze that source code, how to understand the source code, how to process it, and how to publish it. That's how the way our job has to be done. So in that context, we will be helping you on what are the different tools we use it for our own purpose, and how do we go about it. So that's what this we just do. Okay. So there was a question on Professor, I need clarification of ML or DL algorithm import to this. What is the way? Okay. So actually, since there was a question, so many of you were asking about this ML DL. So ML is machine learning, and deep learning needs data set. So ML and DL needs data set. So this is the main issue here, and data set. So feeding the data set is the challenger. Feeding the data set is the challenger in network simulators. But there is one thing called as reinforcement learning is there. reinforcement learning is the third dimension of artificial intelligence. Reinforcement generally we call RL based. So this RL based is can be possible, is possible, not can be, is possible in NS3, particularly a software called as NS3-GYM. There is one software NS3-GYM. So that uses reward function and actions, reward functions and action based on a success and failure, based on success rate. Okay, so if it is success, if a state transition is success, a reward will be given. If it is failure, the reward will be reduced. So that complete AP is given in NS3-GYM. So this NS3-GYM is one platform. There is another platform called as NS3-AI. This also there, but it has some bugs. Still, it is not. There are so many bugs are there. So ML and DL directly it is not possible, but NS3-GYM you can use reinforcement learning for purpose. So maybe I already worked on this area as well on one congestion control algorithm in using NS3-GYM. Maybe if time permits, I can publish that in my one of video. Maybe if they have the video, I'll just share that to you. So if time permits in any of these for next 3 days, I can give you a demo on NS3-GYM so that you can have an understanding of how really reinforcement learning leverages NS3 for some of the applications. I can show you one TCP congestion control without reinforcement learning, with reinforcement learning. I can show you a demo on that. So this is one of the very good research area, particularly this reinforcement learning. So that I can able to show you. But ML and DL, there is no provision for feeding a data set to a NS3 engine. So that's why we cannot do that as of now. Maybe in future it may come if someone able to do some modules or some plugins. But reinforcement learning is possible in NS3. So that I can guarantee that. Maybe I can publish a video also on that. So all these things I just recorded a video. So all this video will be published after some minor editing. So that we'll be doing it. So whatever published yesterday, I have published and then send the link in the WhatsApp group. Maybe I'll let share that as well, so that you can make use of those videos. Okay. So please hold your queries, doubts, any. Senior kindly suggest publish paper in scientific journals. Okay, ma'am. This is out of the scope of my domain. See, I'm just so me and our team, we are good in experimental programmers. Okay, so we do programming, but taking the programming into publishing paper, we also rely upon our scholars and then our students. But anyway, in future, if you wanted to have a collaborative publication with us, then we can able to do. Some amount of experimentation we do, and the other aspects, if you can do, we can able to go for some scientific journals. We can do. Any other queries, friends? Okay, friends, it's almost time. So tomorrow, what is the first session? Okay, actually, so tomorrow there's a slight change in the schedule. So tomorrow there will be one professor from Thursday. He will be coming tomorrow because of some sudden damage of one of the family members of a resource person. So because of that, we will be preponing one faculty member, one resource person to come tomorrow morning. And tomorrow afternoon, we'll have the 6G simulation using Terrasync. So I can able to tell you about how that can be done. So if you are, if you are very serious about this learning this, and please download the VM image, and have just given a new link today, which contains all the, the presentation materials, everything I just uploaded there, so that you can go through and then you can able to do some simple experimentations. Okay. So thank you, friends. So we will again meet by tomorrow morning.